Okay, so far what we've looked at is basically the gradients of functions. So we figured out if I have any curve, let's say a curve that looks like this, what I can determine is the sign of its gradient, whether it's positive, whether it's 0, or whether it's negative. And I can also draw tangents at any point on that curve and find what the gradient of this tangent is. So at that particular point, what is the value of that gradient? And to do that, all I had to do was to find out what's the rise over run. Okay? But now, as you can see, this curve, the value of the gradient in this curve is changing constantly. So at any point, the value of the gradient is quite different. Whereas we knew that if I had a line, the gradient of this line is constant. No matter where I go, it still has the same gradient. So any point on this line has the same gradient. Whereas any point on this curve, if you draw the tangent to that curve at that point, you will see that the gradient or the slope of the tangent is going to be different. So to make life easier, what mathematicians have come up with is to find out what the gradient of these tangents are at each point. So that process is called differentiation. So differentiation, all it's doing is it's saying, okay, if you have a curve, what we can do for you is find out at any point that you say, let's say you want to find it at x is equal to 3. It basically goes here, it draws the tangent, says, okay, this tangent has this gradient, and then it allows you to find the gradient of the tangent at each point. Okay, so that's the whole point of differentiation. Now, for you to be able to see if you can differentiate things, we have a concept called differentiability. So what differentiability means is if I have a curve, am I able to find basically the gradient of that curve at each point? Am I able to do that? So whenever you're trying to find a function that tells you what the differentiation of a curve is at each point, we call that function the derivative function. We'll come back to the derivative function in a bit. But differentiability. So we call any function that's continuous is normally differentiable. What does differentiable mean? So if I have a function like this, you can see that I can go to any point and draw a tangent to that point and find its gradient. Okay, so in this instance, I call this function differentiable. But not all functions are continuous and not all functions are smooth like this one. So for example, if I had a function that looked like this, you can see that there's a big gap in here. Basically, this function can never reach x is equal to minus 1. Okay, so at this point, we say that this function is not differentiable at this point, x is equal to minus 1. And the reason for that is that this function is not actually continuous across points x is equal to minus 1. So one of the main points about differentiability is that first, the function has to be continuous for it to be differentiable across all x values. Another thing is, a function cannot have a discontinuous point. So for example, if I have a function that looks like, let's say, this, you can see here it has a unfilled circle. What that means is that this function includes all values of x except this one that this corresponds to. So let's say a. So we say that this function is actually not differentiable at point A And the reason for that is that it's actually not it's discontinuous. It's not continuous across this. And another point for differentiability is that it has to be smooth. So if I have a function like this function has a sharp edge. So at any sharp edge, you're not able to differentiate the function. What that means is that you can actually draw a tangent to that point and find the gradient of that tangent. And reason being, you don't actually know where the function's going. So does the tangent go this way? Does the tangent go this way? Does the tangent go this way? You can see here, it's really easy to draw a tangent. So the tangent is basically a line which only crosses your curve at this one point. Okay, and because this is a smooth curve, there's only one such tangent. Whereas at a sharp point, it's actually really hard to figure out, okay, where is the tangent? So that's why we say at this point, at this sharp point, we're not going to be able to differentiate that function. So there are three main things. One, it actually can't be discontinuous, whether it's in this format or in that format. And the other thing is that it can't have a sharp point. So at any sharp point, you're not going to be differentiable.